introduction qui est de présenter un petit peu la société Elasticity, qui présente le produit NCache aujourd'hui. Et puis après, on ira plus dans la technique. Je pense que c'est le sujet qui vous intéresse le plus aujourd'hui. Aujourd'hui, on va parler de comment monter en puissance des applications .NET au travers d'un cache distribué. Alors, on peut aussi monter en performance des applications sans Azure avec un cache distribué. C'est la même technologie, c'est tout pareil. Vous pouvez le faire chez vous ou dans le cloud. Mais comme le Azure c'est vraiment le sujet à la mode en ce moment, c'était intéressant d'expliquer comment on peut le faire dans Azure. Iqbal Khan, qui est Technology Evangelist chez Elasticity, va vous faire la présentation technique. Ça sera en anglais, donc si vous avez des questions, n'hésitez pas à me les poser, je traduirai si nécessaire, il n'y a aucun problème. Mon nom est Jacques Lefebvre, je travaille chez Red Fabric, je suis le CEO de Red Fabric et on est partenaire et distributeur d'Elasticity. Alors Elasticity, j'imagine que ça ne parle pas à grand monde. Vous pouvez me dire qui connaît NCache dans l'assemblée? Hein? D'accord. Bon. Alors, en fait, vous avez tous sûrement utilisé NCache sans le savoir, en utilisant par exemple au travers d'un cache distribué. Alors, on peut aussi monter en performance des applications sans Azure avec un cache distribué. C'est la même technologie, c'est tout pareil. Vous pouvez le faire chez vous ou dans le cloud. Mais comme le Azure c'est vraiment le sujet à la mode en ce moment, c'était intéressant d'expliquer comment on peut le faire dans Azure. Iqbal Khan, qui est Technology Evangelist chez Elasticity, va vous faire la présentation technique. Ça sera en anglais, donc si vous avez des questions, n'hésitez pas à me les poser, je traduirai si nécessaire, il n'y a aucun problème. Mon nom est Jacques Lefebvre, je travaille chez Red Fabric, je suis le CEO de Red Fabric et on est partenaire et distributeur d'Elasticity. Alors Elasticity, j'imagine que ça ne parle pas à grand monde. Vous pouvez me dire qui connaît NCache dans l'assemblée? Hein? D'accord. Bon. Alors, en fait, vous avez tous sûrement utilisé NCache sans le savoir, en utilisant par exemple du site où il est à plat. Ça représente 200 000 € de chiffre d'affaires manqué. Je ne sais pas si vous imaginez, mais vous remboursez largement l'investissement que vous mettez dans NCache. Voilà, donc quand vous parlez de performance et d'être sûr que votre site web ou vos web services, ou de la mobilité aussi, la mobilité utilise des web services, on a besoin d'avoir des accès rapides, NCache peut vous apporter une solution sur ce sujet-là. Voilà, donc ça c'est pour un côté un petit peu commercial, on va rentrer dans le côté technique. Donc Iqbal va prendre la parole et n'hésitez surtout pas à nous interrompre pour poser des questions. Il n'y a pas de mauvaises questions et si vous ne pouvez pas l'exprimer en anglais, il n'y a aucun problème, je ferai la traduction pour vous. Voilà. Iqbal.
Thank you.
You want to switch?
Yes. I'll do standing. Hello everybody, my name is Iqbal Khan. I'm the technology evangelist at Elasticity. We are a San Francisco Bay Area based company, as Jacques said. I'm going to dive into technical stuff. The purpose of this presentation is to educate everybody about what are the different problems that you would face if you have an application that needs to scale. If you guys have any questions, please ask me as I'm talking. Instead of waiting until the end, it is better if we just have a more interactive discussion. And if you prefer to ask questions in French, then that's where Jacques will help me. So let's start with a question. I want to make sure everybody understand what is scalability. I'm sure most people do, but I just want to make sure everybody does. So scalability essentially means that you want to be able to increase transaction load, traffic, number of users on your application. Let's say, and get the same performance that you would if you only had 1 user or 10 users. So if you had whatever response time your application was getting with 10 users, if you can get the same response time when 10,000 or 100,000 users are using your application at that time, that means your application is scalable. If you don't have any problems going from 10 to 100,000, you probably don't need this talk because you already have everything figured out. But if you do, and my guess is most of you, if you don't have it already, you will run into these problems. Then you need to understand why those problems occur and how to get rid of those problems. Another definition, linear scalability. People say, okay, well, if I have more traffic, just put on more servers, buy more expensive hardware. But is that going to achieve linear scalability? What is linear scalability? It is that if you add more servers, you should get an incremental or the same rate of increase in your capacity, in your transaction capacity. This is if it's a linear scalability, you're doing really good. But if it is a logarithmic curve, for those of you who have mathematics background, if it starts to, after a certain time, it will add no value. And this is exactly what happens when your application is not scalable. That just by adding more servers, let's say if you add more web servers, you're not going to increase capacity because the problem is somewhere else. So the goal is to achieve linear scalability. So which applications will face this problem? I think it's a very important question to understand. Not every application is going to face this problem. If you're developing embedded systems application, you're probably not going to have this problem. If you have a desktop application with only 10 users, or maybe just a single user application, this is not your issue. But if you have a server application, if you have an ASP.NET application, if you have web services, or if you have big data analytics applications, if you're dealing with this Internet of Things, that it's a big buzzword these days, which basically means that a lot of the mobile devices are plugged into the internet. If you have that, then you have a backend for it. Then you have a problem. Or if you have any other server application, which is high traffic, high transaction, if you do, you will need scalability. So if just think about the types of applications that you're working on now, or what you have done in the past, or what you're going to do in the future. If they fall into this category, then you definitely need to pay attention to this. Let me quickly go over what these applications are. I think everybody knows what web applications are. You can add more web servers to increase it in a web farm with a load balancer. Same way, web services work exactly the same way as web applications. You can have a load balanced web farm. But does anybody know what big data analytics is? Okay. This is where you have so much data to process, and this is most likely unstructured data. It may be coming from social media, it may be coming from a lot of other sources, and you need to make sense of it in a fairly reasonable time. You cannot take weeks and months. You need to take hours and days maybe to make sense of this. And the only way you can do so is if you distribute the processing of it across tens or hundreds of servers and do everything in parallel. So this is the big data being the next buzzword in this. Internet of Things, we've talked about. I think from a scalability perspective, Internet of Things requires you to have something like web services backend. So although today's topic is specific to Microsoft Azure, but these problems are not only going to occur in Azure. If you have an on-premise deployment of your application, you're going to have the same issues. In fact, most people who have had these issues up until now, because cloud has not been that old, they've had these problems in their own on-premise environment. So, but Microsoft Azure is becoming very popular, especially for .NET applications, although Microsoft says that you can use it for all technologies. But The .NET applications are specifically attracted to it because it is a Microsoft cloud platform. So .NET framework is really, a true integration is available. So it is a popular platform. It is becoming more popular for high traffic. All those applications I mentioned, it is becoming more and more popular for that as well. In Azure, here's what a typical application deployment looks like. You may have multiple application tiers here. I'm just going to simplify the picture. So you have a server farm or a number of VMs which are hosting your application. Again, it could be ASP.NET application, it could be WCF, or any other application. And there's probably some sort of a load balancer in case of an ASP.NET application, but in case of other application, then you have other ways that the traffic is being generated. You have different data sources. You may have NoSQL database, you may not. Most people still don't have NoSQL database, but they do have a relational database. That's where most of the business data exists, the structured data, your customers, your accounts. And if it's an ASP.NET application, you definitely have some place where you're storing your sessions. And then if you're a larger company, and you're very sensitive about the security of your data, you're probably keeping your data on premise, even though your application is deployed in the cloud. So this is a typical deployment of your application. And again, keep in mind, this is all inside one Azure virtual network. You could have multiple virtual networks as well that are sharing a common database. So there are all sorts of permutations that you can have on this. So we talked about these applications needing scalability, and you saw that in an ASP.NET you could add more servers, but that doesn't solve the problem. So where is the problem? If the application can scale, it is in the data storage. If you are using a relational database, if you are storing sessions, if you have any other, let's say you have a mainframe, you are going to have scalability bottleneck. If you have a NoSQL database, you're probably not going to have a scalability bottleneck if the NoSQL database is distributed. Not all NoSQL databases are distributed. Some of them are still acting like a relational database behind the scenes, but they just give you a NoSQL interface on top. So if they're distributed, they're partitioning within the data, then they are not going to become the bottleneck, but every other data source, which means that 99% of the applications today are going to have this problem at some stage because they are storing some or all of their data in either a relational database or some other data store.
I ask a question. Qui a des problèmes de performance aujourd'hui dans ces applications? Juste pour avoir un... 3, 4. Donc, si vous voulez en parler après la session, on sera ravis de pouvoir en discuter. Okay.
So here's another way to look at that problem. You're scaling the application tier. You're adding more boxes as you need traffic. Again, there's probably a load balancer here that is balancing the traffic to all of these boxes. So you can add more boxes. But other than the NoSQL database, which is partition means it also looks something like this. Other than a NoSQL database, all other data storage that you have, and I did not mention mainframe. A lot of the web applications these days, they have some sort of a mainframe that they still go to for legacy data because the master database is there. So they are going to be the bottleneck. Well, if anything becomes a bottleneck, it doesn't really matter how many servers you add. What's going to happen? This will choke. If this chokes, the entire application chokes. And the nature of this problem is that this is choking at a very interesting time when your business is growing. You need scalability. Why? Because you need more transaction. More transaction you need. Why? Because you need more customers, more people are coming to your website or doing processing. So even though your business is growing, so your manager, your business side of people are very excited about it, suddenly the engineers tell them, really, we are this big airline, we ran this weekend promotion, 50% off to Hawaii. So everybody who wants to buy that ticket, they come to the website website crashes or slows down, where every click is taking 2 minutes. And when that happens, the cost to your business is very, very high. So, and there's nothing that you can do. You cannot add boxes here to fix that problem. Why? Because the problem isn't there. The problem is here. And you also cannot, you cannot live without a relational database. So if you're going to say, well, don't use relational, use NoSQL, that's not going to happen. NoSQL is only good for unstructured data. So, because your business folks need to run all those reports, they're all the third party. There's a whole ecosystem, as you know, around your relational database. So this could be your SQL Server, it could be Oracle, it could be DB2, it could be MySQL, anything. So you're not going to get rid of your relational database. So if you're not going to fix this by adding this, if you're not going to be able to get rid of this, because you can't move to MySQL, what is the answer? Well, the answer is that you need to use a distributed cache. And this is a very important thing that a lot of people don't understand, is that you need to use relational databases, but you need to fix the problems, and distributed cache fixes that problem. NCache is one of those products that does it, but my purpose here is to talk about the concept. And NCache is an open source product, it's free. And there's also an enterprise version of it that you can use. But if you're not ready to spend money, the open source is there, of course. So, actually, could you go one more page? And I'm going to ask you to come back to this. So here's what NCache does, or a distributed cache does. It's not just NCache. If you have a distributed cache, it's going to let you continue working with your relational database. And if you have NoSQL, then of course you still have. You can continue to have your on-premise data, but these are no longer the bottleneck. Why? Because 70 to 80% of the time, you're no longer going to the database. You're going to the cache. It's an in-memory store. On the Java side, they call it an in-memory data grid. On the .NET side, it's just called distributed cache. And it is distributed because the same cache, this one logical cache, one logical in-memory database, can exist on multiple servers. So you don't care how many servers it is on. Your application just thinks about one in-memory store. And then from a capacity planning, you can add more servers. Just like you can add servers here, you can add more servers here. And the cache never becomes that bottleneck that relational database does. This is the real important point that I want everybody to go back home with, is that with this, you will continue to work with relational databases, but you're not going to have the bottlenecks. And that's the reason why so many people are using distributed cache. NCache, the examples that we talked about in the US at least, and also UK. Let's go back one page. So let's talk about, there are 4 different characteristics of a distributed cache. Number 1, it builds a cluster of low cost. Those are the 2 keywords, cluster and low cost. Low cost means that you're not going to be buying a high-end database server. These are your typical web server type boxes. They just have a lot of memory. And a lot of memory means what? A typical box probably has 16 gig, some have 32 gig, some have 64 gig, some may have 128 gig, but that's about it. Between 16 to 128 gig is the range that most people put in one box, because if you start to put too much memory on one box, then you need a lot of processing power, because you know that .NET is a managed environment, so there's a thing called GC, which stands for garbage collector. And GC needs to clean up stuff, and if you have let's say if you have 256 gig of memory, it's a 64-bit platform, it could handle it, but you need then higher processing power, maybe 4 CPUs. So now you're starting to look more and more like a database, which is not the goal. The goal is to keep it low cost, a 2 CPU box, with 16 to 32 gig is pretty much the average, because you can add more boxes. They're very cheap, I don't know what the price is. And
Like $500.
well, it's going to be a few thousand because you're buying those rack things,
Yeah,
but it's still very
yeah,
cheap.
around 1,000.
Yeah. So that's the first thing. First characteristic is a low-cost cluster, and the cluster means that they all act as one logical unit. Number two, whatever you update on one server is immediately synchronized or made available to all the servers in the cluster. If you don't have this ability, then it is not a distributed cache. And I'll give you an example. Anybody's heard of Memcache? Memcache? Memcache is a really famous, popular distributed cache, but it does not have a cluster. It does not distribute the updates up across. So this is the second characteristic. Third, it linearly scales that we talked about. That you can add more servers, and the memory should grow, and these transaction capacity. So when you add a new server, what are you adding to the cluster? You're adding more CPU, right? Because every box has its own CPU. So you got at least two more CPUs, maybe quad core each. So these are 8 physical cores, 16 virtual cores. You just added 16 virtual cores to your cluster. So that's more processing. So that'll handle more transactions. You're also adding more memory because it came with another 16 or 32 or 64 gig of memory. And because it pools the memory as one logical memory, your storage capacity grew. The third thing that it adds, which is not mentioned here, is that every box comes with its own network card. So the things that can become bottlenecks are CPU, memory, and network card. If you had CPU and memory, but you had, let's say, 100 megabyte or a megabit network card, you're not going to get any performance because the network card will start to choke. So, these days 1 gigabit is the minimum that you have, but even 10 gigabit. So every box adds CPU, memory, and network card. So this is the third characteristic. Fourth is data replication. Again, it's an in-memory store. Unlike a database where it has a disk, so whatever you save in it, it's saved persistently. Here, it is in-memory. So if any one box goes down, it crashes, maybe you need to bring it down for maintenance, whatever, you lose that memory. So the way to handle it is to do replication. Any distributed cache that does not do replication doesn't fall into this category. How many times do we have? Good. So the three. So okay, now that we've established the real reason why you would need a distributed cache, let's talk about what are the use cases. How do you use it? What are the specific things that you do with a distributed cache? So number one, application data caching, which means whatever you were putting in your relational database, your customers, your accounts, whatever, you're caching it now. So whatever you're caching, a copy of it is also in there. So it's two places now. One is in the database, which is the master, and now there's a cache, which is a copy. So it presents a different set of problems and challenges in terms of that data being fresh, and we'll talk about that in a bit. Number two is if you have ASP.NET applications, there's some data, for example, the session, and if you're not using the MVC framework, you still have the view state, and then the output check. This is data at the minimum the sessions everybody has. The view state you may or may not have, but so where do you store it? You have to store it somewhere. Why store it in the database? Because it's not permanent. I mean, you don't need to save it for another 10 years. You need it only for that whatever time that user is logged in. So save it in the cache. So that's the second use case, the most common. And the third use case is something that a lot of people don't know about, which is that when you have these server applications that are doing a lot of processing across multiple servers, they often need coordination between each other. So they need to do event-based coordination. It's called, has anybody here publish, subscribe model, pub-sub, yeah. So one application publishes an event and multiple applications consume it. So the event streaming, currently you use message queues for it,
Some people also use a database. Their events, database notifications are also there. They are not, all of those are not scalable. If you have a high transaction environment, you want to use a distributed cache, which is an in-memory cluster of servers. And because it's clustered, it's scalable to do event streaming. So these three use cases are very important for you to understand. Any questions? Maybe I'm so easy to understand, everything I'm saying makes sense.
Okay. Will you get to explain how it works? Because you have to synchronize the data, so you replace one bottleneck with other issues.
Good. I'm gonna get to that in a bit. So what data to cache? There's a very big misperception that you should only cache static data, read-only data, because everybody's afraid if I cache transactional data. Transactional means it changes. It changes every 30 seconds, 15 seconds, a few minutes. If I cached it, I would have an older copy, a stale copy in the cache versus my database. Well, a distributed cache should provide features to ensure that the cache is never out of sync. And that allows you to cache, because there's a big chunk of data that is transactional data. And keep in mind, if you cache it even for 2 minutes, in that 2 minutes you may read it 10 times. Multiply that by millions of users that might come to your website every day. And there's a lot of database traffic that you just cut down because of the caching transaction data. So you want to cache both reference data, which is that lookup tables, the product catalog, this stuff, which doesn't change very frequently. It's not read-only. It still changes. Maybe it changes every few hours, maybe once a day or something. But you want to also cache this data. Sessions, for example, is a transactional data. A session changes. That session object changes on every request, but you may store new data into it. So that's transactional data. We're going to speed up a little bit. So here's what a typical API looks like. This is very similar to the ASP.NET cache object. So you connect to a cache, all the caches are named. Then you use that cache handle to do cache.get. Another way to do get contains, add, insert, remove. And of course there's more to this. But the point being, it's very simple. You have a key, which is a string. And then you have an object, which is any .NET object. It could be your ADO.NET data table, your record set. It could be your actual domain object. So there, anything that is serializable, you can cache. And the keys are something where you can do play with the format of the key to determine how to cache different type of objects. I'm not going to go into the detail. I'm going to go get to that question. Okay. A cache is like a database. You would not want your database to be crashing because if it does, your application is screwed. So the same way, the cache should have high availability. And the only way it can do that is if it has dynamic clustering. If it has a cluster, you can add or remove servers at runtime without stopping anything. So you can add a server, an application continues to run. You can drop a server, an application continues to run. You don't lose any data by doing any of this. Especially when you drop a server, you should not lose any data. Why? Because it was replicated on another box. Go to the next. Another thing is, because you want to be able to add or drop boxes, you don't want to hard code anything on the application side. So the application should not know what servers are there. They should just have a cache name and maybe just some starting point. Everything else should be dynamic. So that when you add a new server, that information is propagated to all of the clients. If a distributed cache can do that, which is what NCache does, then it is truly elastic, then it can provide you high availability.
I think it's important to say the architecture is a peer-to-peer architecture. So there's no single failing point. C'est en peer-to-peer, donc vous êtes complètement tranquille dans une architecture, elle peut grandir, rétrécir, tout est complètement dynamique. Des questions sur ça?
Okay. So let's go into, so there are 4 different topologies. Topology means how the data is stored and how the connections are made. And there are different topologies for different types of usage. So there's one called mirror topology. It's a 2-node. There's an active, there's a passive. All the data is on the active node. Whatever you update is applied to the passive node. It's done asynchronously. If the active node ever goes down, the passive node becomes active, and all the applications connect to the new active. Here, if the active node crashes, you may lose a small amount of data because it's an asynchronous update. Most people are okay with that because for the application data caching, you first update the database, then you update the cache. So even if you lose some data in the cache, you can always fetch it back. For the sessions, again, most people are okay, but if not, then there are other options that you ensure that no data is lost. Here's the next one. Replicated topology is where you can have more than 2 servers, but every server has the entire copy of the cache. So this is where you do a lot of reading, not a lot of updates. And you can have 2 or more boxes. Each client connects to its own box. They do all the read writes. So whatever you update here is synchronously applied to an entire cluster. So the update does not complete until it's updated here, here, and here. So that's how you ensure the data integrity. Partition cache is where you want scalability. So that's where we were talking about when you add more boxes, more partitions get created, and more partitions mean more data. Let's go to the partition replica. So I'm going to talk about this both for partition and partition replica. So this is the same as partition cache, except every partition has a replica. And this is where all the clients talk to the partitions only. Nobody talks to the replica. The partition talks to the replica. So let's say that you update item number 1 here. This will asynchronously update it in the replica if it's an async replication. Now with async, as I said, there's a slight chance that if this crashes, you may lose a few items. Now, we've got customers who are storing financial data. So for that type of data, they use synchronous replication. Synchronous replication means when the client receives a success, that means it has already been applied to both. So with a synchronous replication, there is no data loss at all. But of course, there's a small performance. But here, because it's partitioned, the performance is only to 2. Even if you have 10 servers, you only have 2 copies. So you don't have 10 copies of the data. So that's why the performance is not impacted, even when you have more than 2 servers in the cluster. Another thing that is very important in a distributed cache is called a client cache. Some people call it near cache. This is a cache that sits within your application process, but it's kept synchronized with the 4 topologies that we talked about. And again, all of that is just done through configuration. Essentially, it's a cache on top of a cache. So the more data you cache here, the less you have to go here. And of course, the database is right here. So even your cache, the pressure is taken off because this could even be in proc. So when it's in proc, it's on your heap. It's kept in an object form and not in a serialized form. So again, these topologies are there to help you maximize your configuration. In the end, when you do all of this, you see a remarkable improvement, not only in performance, but more importantly in that scalability, which is the same performance that you had with 10 people, now you have with 100,000 people. And you can very quickly do the stress testing. And NCache gives you some stress testing tools that you can put the cache itself test it in your environment. So don't take our word for it. Another thing, if you have web applications especially that are deployed to multiple data centers. For example, Ryanair is our customer, and they have a data center in Dublin, one in London and one in Frankfurt. And they do it for geographical load balancing, but also for reliability and for disaster recovery. But all of those are active data centers. You may have an active passive where one data center is just passive until the first one goes down. But a lot of people who have multiple data centers keep them active now because you pay for the infrastructure, so you want to use it. So now you can replicate the database, and even the database you probably don't want to replicate 4 times. But let's say that you're replicating the database, but now that you incorporated caching into your environment. And we talked about it, that it's not only caching application data, it's also caching that transient data, which is the session, the view state, or any other data that is not even going in the database. So when the cache is the master store, when the cache becomes a master store, if you don't replicate, you cannot deploy the application in a multi-data center environment. So that means that cache is no good. Either you compromise on the high availability part, or you pick a cache that will do it. NCache has the WAN replication where you can do this. So the cache also replicates. Whatever you update here is asynchronously applied here. And because it's active, there's conflict resolution. Now, intentionally, this is asynchronous. It's a queuing architecture, because if we didn't do a queuing architecture, the latency in the WAN would just kill the performance. I mean, if you ping a server in California from here, the ping time is going to probably be 20 to 40 milliseconds at least. I don't know what it will do. You can even test it, but So if every request took 40 milliseconds to come back, I mean, your application is holy. Because NCache, an average cache operation is in a sub-millisecond performance. So when you multiply that by 50 milliseconds, you're talking 100 times or 1,000 times slower. So that's why you need to do a queuing-based architecture. Any questions? I've been talking a lot. I know there's not a lot of time, so I'm going to get everything out.
Est-ce qu'on a répondu à votre question ou pas?
Pas entièrement.
Alors, quelle est la partie qu'on n'a pas répondu?
C'est-à-dire que, puisqu'il y a un mécanisme de synchronisation, si on va chercher une donnée, on n'est pas sûr que ce soit la toute dernière. Elle aurait pu être mise à jour par ailleurs.
Okay. Okay. Maybe I can answer that. The question is, if you on the database, if somebody goes directly to the database, changes something, how do you make sure the cache is up to date?
Good question. Let's move to about 4 or 5 slides down.
Down. Okay. Yeah, I know.
One more. Yeah. There it is. So I think very good question, because the cache is a copy of what is in the database. What happens? I mean, if your application is the only entity updating the data, you will update the database and you'll update the cache, no problems. But in any real world, things are not that simple. There are going to be third-party applications, there are going to be other batch processes that'll go and update the database directly. If that happens, you want to be able to synchronize the cache with the database. So NCache, for example, has this SQL dependency feature for SQL Server, and Oracle dependency for Oracle, and DB dependency for any other database. It could be MySQL, DB2, it's just any OLE DB. And these are event-based, by the way. So it will use database events. So when the data changes, the database will fire an event, a .NET event, NCache will catch it and will either invalidate, means it will remove that item from the cache, or it might load a new copy of it. If you have implemented a read-through handler, which is the slide before, which is that it is your code that NCache can call to go and read the database. The NCache calls you the read-through and reload. So it can reload items on expirations or database synchronizations. But if you don't have the read-through, then it'll just remove that item. Meaning that next time your application is looking for it, it will not find it in the cache. It'll go and get it from the database. So that's one way. There are 3 different ways that you can synchronize. One was the SQL dependency, one is polling-based DB dependency, where the cache polls the database. Let's say if you have DB2 or MySQL, which does not have this eventing architecture, then NCache will poll. The third is that you can actually, in case of SQL, you can actually implement CLR procedures. The stored procedures in the database could be CLR procedures, and they could make NCache API calls. So you could have a trigger. Let's say if you're updating a row, that the trigger gets called, and this the call is to a CLR procedure. The CLR procedure makes an async call to NCache because you don't want to make sync call. Async means it'll pass it on to cache and say, please update this item, and then go back because the database transaction is waiting until that trigger completes. So that is how you ensure that the data in the database and the cache is always synchronized.
Répond à votre question.
Oui, en partie.
Allez-y.
Après, I'm sure there is always some kind of drawback when you implement it. There are trade-offs when you use a cache solution or not on there.
But actually, I mean, keep in mind that almost always the number of reads is about 70 to 90% of your traffic versus the updates. So the updates are not as many as the reads. So this is a cost on the update. So even if there's an extra step now that you have to take, and again, this is only when a third-party application is updating, which may not happen all the time. It may happen in a batch, maybe once a night, when it goes and updates. And maybe at that time, the user traffic is not that high anyway. But in the peak hours, most of the time, and again, I'm saying the updates are originating from your application. And when that happens, then you don't need this feature because then the application updates the cache as well as the database. And the trade-off is very manageable because the updates are about 10 to 20% of your overall activity. It's the reads that really help.
Another question about, you talked about sessions. I imagine that actually it's easy to distribute sessions because they are not related to one another.
Right.
On there.
Right. But what happens, let's say in this case, what happens when you route, a user, let's say, went to one data center, they went to the London data center, and now you route them to Frankfurt. The session is still going. You want the ability, you don't want that user to lose the session.
Of course. In case of multiple data centers.
Exactly. In case of multiple data centers. In case of the same data center, a user comes to this box where the session is created. The next time the user comes, is going to probably go to this box because you want true load balancing.
Yeah, but you could have several servers with 4 sessions.
If you have, for example, then you would have to send that user back to the same server where the session was created.
Yeah, but it could be on another tier and distributed.
So that's what this would do. So that is the tier where you have the. So if you have, for example, the option that Microsoft gives you is either you store them in SQL database or you store them in a state server, which is not even available on Azure. The state server is only for on-premise. There's no replication. So so there's no. So again, it's not only the distribution; it's also whether the session is replicated or not. If it's in SQL, then it's okay. But SQL has performance issues. I mean, that's why you do application data caching, and the sessions are stored as blobs in SQL. And SQL, any relational database was not designed for blob storage, but a distributed cache stores everything in blobs.
En fait, le stockage de la session vous impose des choix techniques de load balancing qui sont plus drastiques et plus coûteux. Alors que si vous libérez en fait votre session, qu'elle est complètement répliquée sur tous les data centers, vous pouvez accéder à ce que vous voulez. Le load balancing, il n'a plus de restrictions. Et vous avez une meilleure performance de cette manière-là.
Il me semblait que ces restrictions étaient pas très gênantes.
Si vous avez beaucoup d'utilisateurs, comme peuvent avoir la plupart des clients de NCache, ça peut devenir rapidement dramatique en termes de pic. Par exemple, qui a déjà été ralenti sur une réservation d'avion en soirée? Oui, c'est un vrai problème. Quand vous avez 3 data centers et que vous n'avez aucune contrainte sur quel data center vous envoyez votre client, vous avez plus de problème.
I mean, this is something, once you try it, you'll very quickly see the benefit. Especially in case of session, there's no programming needed. It's just a module plugs in. You can have this thing up in less than an hour, and the application, and you'll see that there's an immediate benefit.
Is it a solution that's already provided by Azure, or that's something you have to implement in Azure with your?
NCache is available in Azure. We're putting it on the marketplace as we speak. So there's an open source version of NCache, which will also be on the Azure marketplace, which is free. So you're only paying for the VM. And then the enterprise edition will also be available on Azure. So it's going to be a VM. You just get the VM from the marketplace, and it's there. So it is going to run perfectly fine. It already runs perfectly fine in Azure. If your application is in Azure, you can use NCache. If your application is on-premise, you can still use NCache. I would say go and download. Just start with open source. If you're not ready to think about it, just at least play with open source. If you are, the enterprise edition is a fully working copy for 2 months, and it can be extended to be more than 2 months.
I want to go very quickly through the last slides because we are already.
I think they just go to our website. There's just too much. There's no way that we can complete this. So just go to our website. Just do all tab. And then go to the website.
Vous avez d'autres questions? No?
How many people knew about distributed caching? Did anybody know about NCache before?
There is something cache, called cache in Azure, I think.
It's called Azure Cache. Behind the scenes, it is using App Fabric, but Microsoft, it looks to me, and again, I'm not speaking on their behalf, it looks to me that they're moving away from the Azure cache, and they are now incorporating Redis, which is another open source cache. But when you compare NCache with that, you'll see that it's a totally different league. And again, because NCache is also open source, so why not just go with it?
Sur le site d'Alachisoft, il y a une comparaison de NCache avec tous les compétiteurs majeurs dans ce domaine-là. Vous pourrez voir les comparaisons.
Thank you very much. Appreciate your time.
Ceux qui ont des projets, s'ils veulent nous parler, n'hésitez pas.
Ouais, c'était plus en termes de géolocalisation et de soucis par rapport aux performances qu'on peut avoir dans